start the tutorial 9, okay, or these sheets, okay, we'll use it from this week, week 9, until next week, week 10. Some of the topic, curvature, arc length will be covered next week. So question 1 and 2 involve curvature and arc length. So we move to question 3 first. Question 3. Okay, describe in words the curve given by RT equal to 2t minus 4i plus 3t plus 1j plus 5pk, where the t from 0, okay, up to 3. Muhammad Firdaus. Muhammad Firdaus.
Sorry.
So now, can you please answer, okay? Just describe in what's the curve given by question 3a here. Basically, straight line, circle, ellipse, quadratic graph, or what? This is the last slide we have shown, okay? If you attend, okay, listen the last slide lecture, you should be able to answer it. What's that? If you cannot answer me, each time I ask any question, nobody respond, only the same person respond. The rest, I'm not sure whether you're listening or not. So what is that? I will give you, is it linear graph, circle, ellipse? Yesterday we covered 3 types of graph, of helix. Circle, is a circle in the 2D. Okay, here you got up to K, so this must be 3D. Or is it the circle or ellipse or helix? Last time we described 3 types of graph. Which one? Muhammad Firdaus. Muhammad Firdaus, okay, are you 3 of it? Can you choose? Which one? Circle. Can you answer loudly? Which one? Circle, straight line, ellipse, or helix. Yesterday we covered 4 types. Circle, ellipse, straight line, or helix. 4 types. Last time we covered 4 types of graph given by vector value function. Now pick 4 of it. Which one? So, you don't know. So each time whether you all listen or not, you don't know.
I listen, but
and each time I ask any question, no response at all. And then when I ask you now, this one have been taught last night only, and then you said you don't know, mean you're not focused, or you all just take attendance and then go to do other things and listen.
No. Later, I watch the video listen to record.
So you watch it, I mean you cannot catch up now. Otherwise, you know what's this one. It's okay. The first example is shown before this one. I can show you back. First example. Describe the graph of RT equal to 3 minus Ti plus 2Tj plus 4 plus 3Tk. The answer, this is a straight line in 3 dimensions. Okay, in 3 dimensions, and the straight line equation is actually, it says in vector value function, component I, let it equal to x. So x equal to 3 minus t. Component j, let it equal to y. Y equal to 2t. Component z, let it equal to, component k, let it equal to z. So this is a parametric equation. This parametric equation represents, last slide is in the PowerPoint where I write, this one is in the text. The note also have been given in the author. Okay, we already said, okay, when you look at this parametric equation, x equal x naught plus at, y equal y naught plus bt, z equal z naught plus ct. Okay, this is a straight line in 3 dimension, 3 space, where this straight line passing through x naught, y naught, z naught, and this straight line is parallel with a vector, okay, given by ai plus bj plus ck. Exactly the same thing now is only. So the answer is based on that first example. This one is a straight line passing through. Okay, you just change it. Okay, 2t minus 4, or component I here is the same thing. Component I, let it equal to x. So x is actually negative 4 plus 2t. Y is actually, this is 1 plus 3t. Okay, z, component k, let it equal to z, so it's 0 plus 5t. So this is actually the straight line. Okay, a straight line passes through, passes through the point. Negative 4, 1, 0. Means x is negative 4, 1 is, y is 1, z is 0. Negative 4, 1, 0. And okay, parallel with, because okay, we have 1 point. So okay, normally straight line you must have 2 points, but using parametric equation we will know passing through a point and parallel with a vector. Okay, vector v. Okay, where the vector v is actually from the coefficient of the t here, which is 2i. X is a 2i. This is 3j plus 5k. Okay. Because in the parametric equation we can only know, okay, the point passing through and the vector. Okay, so mean this straight line, in 1 point we cannot draw the straight line, you must have 2 points. But if we know the direction is actually parallel with this 2i plus 3j plus 5k, then you can connect it parallel with this vector. So you can get a straight line pass through this point and parallel with this vector b. So this is the answer. It's not suddenly we ask you. We have taught you last night. So unless I don't know whether you're focused or not. First example. If you want a circle is example 2a. RT is cos ti plus sin tj. And the video is there, okay? If you're not focused, I hope you revise back the video by yourself. So this question 3a, the answer is this. It's a straight line passes through the point negative 4, 1, 0 and parallel with a vector v equal to 2i plus 3j plus 5k. Because you want to draw in 3D difficult, just explain it. That's why they say describe in words only. So this is the answer. Okay, and question B, given RT equal to the E exponent Ti plus sub T minus 2J plus 1 over T minus 2K. Find the domain for RT and evaluate the limit of RT when T approaches 2. it is RT a continuous function everywhere for T. Okay, so this is related to domain. Okay, domain, and okay, second part is a limit of RT and later on continuous. Continuous later on explain to you. So find the domain. Yesterday also we have shown to you to find domain. We find the domain of each component. To find domain of the vector value function, you find domain for each component, and then the result is actually intersection of the three components. Then you get domain for vector value function RT. So means from here RT equal to exponent 3i. Okay, let's look at the component I. Always like to read Ahmad Abdinasir. Ahmad Abdinasir, tell me the domain for component I, where the function is ET, exponent T. So what is the domain? Ahmad Abdinasir, are you around? Ahmad Abdinasir?
Yes.
Yeah, tell me the domain for component I. What's the domain for exponent T? Exponent T. So your domain is actually the T here. Exponent T, can you take, is it any restriction for exponential function? So that the function can be defined, any restriction or not? Okay, domain you have covered in the first chapter, in the test 1 already. Don't say you don't know how to find the domain. Now, what's the domain for exponent T? Ahmad? How can you all score very well in the test 1? Ahmad Abdinasir, can you respond? What is the domain for exponent T? What is that?
Domain is
exponent T. The function is exponent T. So what is the domain for exponent T?
0.
0. Exponent T, why is 0? Can you sketch the exponent T graph?
What?
I think up to chapter 3, you don't know what is domain. Do you know what's the exponential graph? This is a graph of y equal to exponent T. So from the graph you see, can exponent T, is it any number that cannot be taken or not? Okay, from the graph y equal to exponent T, actually T can take up all the value. So that's why component I think up to now you all still not understand what is domain. To understand domain, make sure you understand the basics graph there. From the graph of y equal to exponent T, you see the graph here is actually, T is actually, you can take up the value from negative infinity up to positive infinity. That's why domain for component I is actually, means that T is a member of real number, no restriction at all. You can take up all the real number. Ahmad, can you understand now?
Yes.
I really wonder until this one is actually the lesson from chapter 1, function of several variables. The first subtopic we learn domain. If you still can understand, and actually when you separate it, this like domain of function of one variable that you have learned, I think in secondary school. If you cannot answer here, means I don't really know what you all learn. And if I ask any question, nobody want to respond. And then for component J, let's call Daniel. Daniel, what's the domain for component J? Any restriction for when you have a square root function here?
Yes.
Yeah, so what's the domain for component J?
Domain for
when you have square root functions, you have to set what? In order the square root function to be defined, t minus 2 must be what? So from
not equal.
Not equal? From chapter 1, we already mentioned yesterday also we revised it. When you have the square root function, you must set whatever under the square root function greater and equal to 0. Example 1, last night. When you meet any square root function, you have to set whatever inside the square root function here, because inside the square root is t minus 2. You must set it greater and equal to 0. Why we set it greater and equal to 0? If you not set it greater and equal to 0, then you have a square root negative number. Then you get some complex number. The functions here is only defined for real number. That's why when you have the square root function, set whatever inside the square root function greater and equal to 0. And then you get t greater and equal to 2. So now it's week 9 already. You still not grab the concept in chapter 1. Then for component K, no, Natasha. Natasha, what is the domain for component K?
T is not equal to 0.
T not equal to 0, why? Your denominator is t minus 2. And why is that t not equal to 0? Why did not take 0? Domains, you must find any restrictions. If you have the quotient function like this, we don't want denominator become 0. Because if the denominator becomes 0, you have 1 divide 0, which is infinity. We don't want that. Infinity is not a real number. That's why when you have a quotient function like this, you always set whatever at the denominator, t minus 2 cannot be equal to 0. Then t cannot be equal to 2. So this is the answer. Mean when t equal to 2, 2 minus 2, 0, 1 divided by 0, infinity. Cannot. So this case, but exponent t, there is no restriction when you see the graph of y equal to exponent t. You can take up all the value, from negative infinity up to positive infinity, but not included infinity number there. So domain for component I state that t can take up all the real number. Component J said that t must be greater and equal to 2. K said t cannot be equal to 2. So you combine these three, intercept these three. That's why, lastly, the answer domain for the vector value function Rt is only t greater than 2. Because I give you a very broad, t is a member of real number, very broad range. J said t greater and equal to 2, but K said cannot be equal to 2. We have to find the intersection. So that's why lastly it's only t greater than 2. So for vector value function, it's only a new thing, intersection of these three components. The rest are actually counted from function of one variable. You should have learned in metric relation or SPPM, or from your secondary school. And in vector, in the first chapter, function of several variables, also gone through domain and range. And then now when I call, I only call two questions and notice that you all cannot answer at all. So this the answer is t greater than 2. Okay, when the t is a member of real number. Okay, so this is the domain. Okay, and evaluate the limit of RT when t approaches 2. Limit of RT when t approaches 2. So equal to find limit at each component. So limit of ET when t approaches 2 at the component I plus limit square root t minus 2, okay, when t approaches 2 at component j plus limit, okay, 1 over t minus 2. So you find the limit at each component. To find the limit, okay, first thing you try to substitute when t approaches 2, you plug in 2 here. You can get answer into, so the limit will be exponent 2. Okay, and then when t equal to 2, I plug in here 2 minus 2, so you get 0j. Okay, when t, okay, but component k, when you plug in 2, 1, 2 minus 2, 0, 1 divided by 0 is infinity. Okay, so if one of the component you get infinity, so we say limit of the vector value function doesn't exceed. Because one of it will get infinity. This one, okay, when infinity is exactly what we call undefined. Okay, and then because the component k is undefined, so we said the limit t approaches 2 for vector value function rt, okay, does not exist. Does not exist at the point t equal to 2. Okay, because one of the component is undefined, that's why limit does not exceed at the point t equal to 2. And then to answer continuous or not, okay, if the limit doesn't exceed, then the function is not continuous. Because to get continuous, okay, mean for example, the graph, okay, if you view it graphically, if you want continuous, okay, function like y equal to exponent a, this is continuous. Because mean you can draw it without picking off your pen. Okay, or first thing, okay, first point to check if limit does not exceed, then the function is not continuous. Okay, so the answer sin since the limit rt when t approaches 2 does not exceed, hence the rt is not continuous function. is not continuous. So that is the answer. Okay. The answer for limit is limit does not exceed because component k is undefined. When you get infinity is undefined. Okay, once the limit does not exist, then the function, okay, the vector value function rt is not continuous function. Okay, and question C. Okay, a force F equal to cos 2ti plus t minus 1j plus exponent negative 3tk Newton is applied to an object of 2 kg at time t equal to 0. The object rests at the origin. Find its position at time t. The object rests, so normally you have no initial velocity. T 0 equal to 0. We want to find position, so we want to find vector rt. So at time t, so to find position vector, you need the velocity vector vt. Before you can get velocity vector, you have to get the acceleration vector. And from physics, you know that F equal to the mass times acceleration. F equal to ma. Okay, m is given here. M equal to 2. F is given here. That's why the A is actually acceleration vector is A is actually F divided by M. We're taking this F divided by M, we have put the vector in this notation. So mean you have the cos 2t at component I, component j is t minus 1. Okay, I lazy to write ijk, so I put in this notation, less than okay, cos 2t comma t minus 1, so this is actually plus t minus 1j, exponent negative t 3tk, okay, divide by m which is 2. So mean this is the at. A is function of t. And okay, your a acceleration vector cos 2ti plus t minus 1j plus exponent negative 3t divided by 2 plus the mass is 2. So given the at, then when you integrate, you can find vt. With vt, you integrate at vt. And you just do the integration. Okay, half is constant, you may factor out half, and then you integrate vector, the result still vector, cos 2ti, so t minus 1, j exponent negative 3t, k dt. Okay, when you integrate vector, each k, your result is still vector, that's why you just integrate each component as usual. Okay. Integrate cos 2t, you have sin 2t divided by 2. Integrate t minus 1, so you have t squared over 2 minus t for component j. T squared over 2 minus t. Integrate component k, we have exponent negative 3t divided by 3. Okay, plus c1. c1 is a vector. The constant c1 is a vector. To get C1, you must have the initial condition, okay, where the initial condition is actually, just not, the object is initially at rest, okay, and okay, V is also vector, so this one can put it as a vector 0, 0, 0. Okay, when T0, your velocity vector at component I, J, K all are 0. Okay, we put in when T0, so we have V0. Since 0 is 0, T0, so this one you get 0. Exponent 0 is 1, so you have 1/3 plus 1 equal to C1 just now, when T0 initially the object at rest, so the velocity we have 0, 0, 0. It's 0i plus 0j plus 0k. Once you can solve it for C1. Okay, so the C1 is 0, 0, 0 minus 0, 0, 1/6. So it's 0, 0, negative 1/6. Because component I, j are 0, only component k is 1/6. Brought to the right hand side, so minus 1/6. So C1 is 0i plus 0j minus k 1/6. So add up back here, C1, you get your Vt. So the Vt, Vt component, add up with component C1, component I is 0, component j is 0, only component k you minus 1/6. So you have your Vt is half sin 2t over 2 t squared over 2 minus t exponent negative 3t over 3 minus 1/6. So this is the Vt. This one half here, expand in, so this is sin 2t over 4, so t squared over 4 minus t over 2, half expand in, so this is 6. Because if just now I put up half there, so this one is to be 3. So better I expand in. I repeat one more time for questions K3C. F is actually MA. We want to find position vector, but now we just find up to velocity vector. So A is a vector F given divided by M. From AT you can find Vt by integrate your AT dt. The integral constant is a vector because the object is initially at rest. So the vector, when T0 velocity is at 0i, 0j, 0k. Once you can find the C1 is actually 0i, 0j minus 1/6. Okay. And then you add up here with C1. With C1, so component I half expand in, so it's sin 2t over 4. Component j, you expand the half inside, so t squared over 4 minus t over 2. Then this component, exponent negative 3t divided by 6. Okay, add up with C1. C1, component I and j is 0, so it won't be effect. So any effect as here, add up to negative 1/6. So this is the Vt. So do you have any question before we proceed to the RT? Nojeti? Are you around, Nojeti? Nojeti, are you around?
Yes, doctor.
Since you have no questions, so from VT, how to find the RT? Okay, from AT, we already integrate, we get VT. So from VT, we want to get position vector RT. So how to obtain RT? Find its position at time t. So mean this one we want to find RT. Okay, I just ask you simple question only, not yet ask you to solve. So Nojeti, from VT, velocity, is actually from force, given force, okay, and m. Then you can find acceleration. From acceleration to get velocity, you integrate. Okay, from velocity, how to get RT? That is my question. Not yet ask you to solve. How to get RT? Integrate or differentiate?
Integrate VT.
Yes. RT, you have to integrate VT respect to T. Okay. So again, integrate like just now. Put it in the vector form. Integrate sin 2t over 4 I t squared over 4 minus t over 2 j, and then component k is exponent negative 3t minus 1 over 6k dt. Okay, integration of vector, the result still vector. Result still vector. So integration, we must have integral constant. So the integral constant in this case is vector 2. So integrate sin 2t, you have negative cos 2t, divide by 2 and divide by 4, so total is divide by 8. Divide by 2 here. So cos 2t over 8 at component I, and then integrate t squared over 4, have t cubed. So divide by 3, so 4 times 3 is 12. Integrate t is t squared divided by 2, already have 2, so total is over 4 of component j. Okay, for component k, okay, so integrate exponent negative 3t, so you have to divide by 3, so total is 18, and then here, integrate 1, so I have t over 6 is at the component k. Okay. Plus vector c2. Once again, integrate sin 2t over 4, negative cos 2t over 8, t squared over 4, t cubed over 12, integrate negative t over 2 to t squared over 4, integrate exponent negative 3t over 6, so exponent negative 3t over 18, integrate negative 1 over 6, so negative t over 6. Okay, and then how to find C2? Okay, this tell you at time t equal to 0, the object rests at the origin. Okay, origin. So mean when t equal to 0, R0 is actually origin is x0, y0, z0. So the vector value function R0, you have 0i plus 0j plus 0k. So with this you can find vector C2. So this is RT, then R0. When T0, okay, it rests at the origin, so okay, vector R there is 0, 0, 0. Now we plug in T0, cos 0 is 1, so negative 1 over 8. Okay. And T0 component j is 0. Okay, exponent 0 is 1, so 1 over 18, because this term when T0, this term is 0. Okay, plus C2, Okay, when T0, the vector R0 is at 0i, 0j plus 0k. So with this we can find C2. So C2 will be a vector 0, 0, 0, 0i, 0j, 0 plus 0k minus, that is negative 1 over 8, 0, 1 over 18. Negative, negative, so component I become positive 1 over 8, 0j minus 0j, so it's 0, 0 minus 1 over 18, and component k, so it's negative 1 over 18. And then to get the RT, add up with the vector C2. So the RT is here, component I, add up with component I from C2. So RT is negative cos 2t over 8, component I, add up with I, so plus 1 over 8. Component J, add up with component J in C2, which is 0. So it's t cubed over 12 minus t power 2 over 4. Okay, component K here, add up with component K from C2. So exponent negative 3t over 18 minus t over 6 minus 1 over 18. So this is a vector, position vector. So the answer is here. So the position vector, lastly you have negative cos 2t over 8 plus 1 over 8i plus t cubed over 12 minus t squared over 4 plus exponent negative 3t over 18 minus t over 6 minus 1 over 8. There's a mistake here. Integrate exponent negative 3t integrate exponent negative 3t is exponent negative 3t divided by negative 3. So when plug in t0, since 0 is 0, okay, component j is 0, so this will be negative 1/3. This is negative 1/3. So half time negative 1/3, so this is negative 1 over 6. So minus and negative C1, this is positive 1 over 6. So this is positive. So this one is positive. So this is positive. So when this is positive, and then when T0, cos 0 is 1, so negative 1 over 8, component J0, component K, okay, component K, okay, 0, Again, this one, got mistake. Integrate exponent negative 3t. So divide by negative, so this is negative 18. Integrate exponent negative 3t, you get exponent negative 3t divide by negative 3, so negative 18. So okay, this part is correct, t over 6. So this will be, when t0, exponent 0 is 1, so this is negative 1 over 18. So to get C2 is a 0 vector minus 1 over 8 is 0, negative 1 over 18. So C2, negative, negative, so component I is 1 over 8, component J 0 minus 0 is 0. And then component K 0 minus negative 1 over 18, so this is positive 1 over 18. Difference RT, it takes a negative cos 2t over 8, add up with component I from C2, so plus 1 over 8, component J for RT initially, t cubed over 12 minus t squared over 4, so add up with 0 to get back the same expression. Okay, component K, here, this is negative exponent negative 3t over 18. Okay, and then this is plus, it is plus t over 6, t over 6. Okay, plus t over 6 and add up with C2, here positive. So the correct answer, okay, I repeat one more time, the RT is negative cos 2t over 8 plus 1 over 8, I. Okay, component J, t cubed over 12 minus t squared over 4. See when I copy it down one. Down here, half times negative. This is negative. Half times negative 3. Okay, Vt exponent negative 3t divided by negative 6. Okay, got negative 6. So integrate exponent negative 3t over negative 6 divided by negative 3. So this one positive back. Just now, okay, here. Initially, the mistake here, integrate exponent negative 3t, you get exponent negative 3t divided by negative 3. So times half, okay, times half, that's why my Vt, this part, this is negative 6, then this is for Vt. Okay, repeat one more time where Vt is sin 2t over 4. At component I, component J is t squared over 4 minus t over 2. Component K is exponent negative 3t over 2 times negative 3. So negative 6. This C1 we obtained is actually plus 1 over 6. Plus 1 over 6. And then when we integrate Vt here, negative 6, exponent negative 3t divided by negative 3 again. So this is positive 18. Positive 18. Plus t over 6. Then when plug in t0, cos 0 is 1, so negative 1 over 8. Component j is 0. Okay, this is positive. Okay, this part is positive, and then this exponent 0 is 1, so 1 over 18. When plug in t0, this term is 0, plus c2, plus the object rests, okay, when t0, the object rests at the origin, so the position vector is at 0i, 0j, 0k. So with this, you can find the c2, C2 is a zero vector minus negative 1 over 8 I minus 1 over 18K. This one negative. This one click here, positive, positive. So C2 is positive 1 over 8 I 0J. This is negative minus 1 over 8. So this is what is correct, negative. C2 component K is negative 1 over. Okay, and then lastly the RT negative cos 2t over 8 plus 1 over 8. Component J cos it plus 0 get back the same. Component K exponent negative 8 negative 3t over 18. This is positive. Plus t over 6, this is negative. Negative. This one, positive, positive, negative 1 over 18. So this is the answer for position vector. So any questions here?
No, nothing.
Maybe you all do one question rather than I thought each time no question but ask you cannot answer. Question 4. Sketch the curve given by RT equal to sin Ti plus 2 cos Tj plus sec 3k. To sketch the graph, I said ij here. Component I let it equal to x. Component j let it equal to y. Component k let it equal to z. So the x equal to sin t. Y equal to 2 cos t. Z equal to sec 3. So, okay, from you have sin t cos t. Normally, can you guess whether this one, which graph that you get, circle or ellipse? Ellipse, huh? If the coefficients, okay, for this is 1 sin t, this is 2 cos t, then you get ellipse. If the coefficient is same, you will get circle. And this ellipse is actually because you have component z equal to 3, raise up the ellipse at z equal to sec 3. And the direction of the ellipse, since they didn't give you the directions, normally you should have, let's say, something like this, so that we can see the direction clockwise or anti-clockwise. So you can square, okay, for x and y here, you can square it. So x squared equal to sin squared t. For the y, you square it, y squared equal to 4 cos squared t. Okay, and we want the term sin squared t plus cos squared t. That's why this one you make it y squared over 4 equal to cos squared t. Like yesterday, we have already mentioned to you, okay, the 3 example. Right. The first one, example 2a, this is a circle. Example B, 2b, this is an ellipse. Coefficient for cos t and sin t different value. So you get ellipse. Okay, and we know that sin squared t plus cos squared t is 1. Sin squared t is actually x squared. Cos squared t is actually y squared over 4. So this is an ellipse because the coefficient for x squared, y squared are different. So this ellipse is actually x squared actually you divide by 1. So mean the x-intercept is from negative 1 to positive 1. Y-intercept is from negative 2 to positive 2. So mean say x, this is 1, this is negative 1, this is 2, this is negative 2. Then you sketch your image. This cos k, when you let y 0, x squared equal to 1, so mean x is negative 1 to positive 1. When you let x squared 0, y squared equal to 4, so y will be negative 2 to positive 2. To know the directions of the ellipse, okay, you have to plug in, let's say, okay, t, and then you put up, this is x, this is y. Okay, because z is constant, so z is always at the position z equal to sub 3. So when t is 0, plug in, sin 0 is 0, cos 0 is 2. So mean when t is 0, x is 0, y is 2. Okay, this one. We start at here. Okay. T is 0, x is 0, y is 2. Later on, let's say t is pi over 2. Sin pi over 2 is 1. Cos pi over 2 is 0. So we move up to here. So the direction is clockwise. So the direction is clockwise. And then the curve is actually, you raise up this curve at position z equal to 3, cos z equal to 3. And you may raise up, put it this one. Let's see. Extra x, y, z. Raise up the ellipse to x. Let's say x, 1 here, negative 1 here, y longer, 2 here, 2. Here, raise up, see of the ellipse. This is at searching. In the drawing is not that good, but I hope you understand. Here, let's say this is 1 to negative 1, this is 2 up to negative 2. When you raise up the ellipse, okay, raise up the ellipse at the position z equal to sub 3. Next class I'm going to show, okay, you in method you can sketch, okay, the vector k function easily. But I have to search back the coding. Okay, this one, raise up the ellipse at the position z equal to 3. That's a part A. For B, let RT equal to sin 2ti plus sec 3t plus 1j plus ln t minus 1k. Find the domain for the RT and evaluate the limit of the RT at t equal to 1. One is R a continuous function. Again, keep finding domain. So, okay, we look at the component I. Okay, sin 2t. Sin 2t. What is the domain for sin 2t? No, Hafiza. For the graph of sin 2t, is it any restriction? Hafiza, what is the domain for sin 2t? Yes, Hafiza. Can you answer? What's the domain for sin 2t? Cannot hear, can you speak loudly?
Okay.
I cannot hear what you are asking. For sin 2t, what is the domain there? Sin 2t. What's the answer?
Yes, saya.
Yeah, what's the sin 2t, what's the domain there? Real number or any number that cannot take?
Any number.
Any number, yes. Because graph of sin is actually non-stop. So Kt is a member of real number. Graph of sin or cos is actually non-stop. It define from negative infinity up to cos infinity. So okay, component I, t is a member of real number. Component j, again sec 3t plus 1. No adila. No adila. Component j, what is the domain? If you have the square root 3t, sec 3t plus 1. No Adila, are you around? No Adila? No Adila? No Adila, are you around? No Adila. That's why. Wonder whether you're all sitting in front of the computer or not. No Lydia, I want to help people to answer. Can you speak loudly? I couldn't hear. No Lydia. No Lydia? Cannot hear. Cannot hear. Can you speak loudly? Yeah. For sec 3t plus 1, what is the domain? You have to set what? You set 3t plus 1 greater than equal to 0. 3t greater than negative 1. So t greater than equal to negative 1/3. Is it? Okay, thank you. So when you see square root function, you must always set whatever inside square root function greater than equal to 0, because we can have square root 0, you get 0, no problem. But we cannot have a negative number. That's why we set 3t plus 1 greater than equal to 0, 3t greater than equal to negative 1, so t greater than equal to negative 1/3. Okay, component k, ln. Okay, for ln t minus 1. Lydia. Okay, when you meet with ln function, what should you set? Aurelia, are you around? Aurelia? This one is not effective, whether you're all sitting at the computer there. Aurelia? Okay, Aprilia, for ln t minus 1, how to get the domain? What should you set when you meet with ln function? You can just sketch ln t. Ln t graph is like this. This is 1. This is y, this is t. So Aurelia, okay, when you have ln, what should you set? For ln t, okay, t must be, for ln function, you have to set, okay, this is y equal ln t. Ln function is defined only when t is positive number greater than 0. As I said, your basics is not, okay, it's not strong at all. Yesterday also, okay, we have gone through, but nobody asking. Okay, for ln function, you have to set t minus 1 greater than 0 because from the graph of y equal to ln t, ln 1 is 0 and ln 0 is undefined. That's why t you have to set greater than 0. For ln t minus 1, so you have to set t minus 1 greater than 0 or t greater than 1. And then okay, the domain for vector value function, you have to combine these three domain. So okay, from component I is brought, okay, is t is a member of real number. J, component J tell you t greater and equal to negative 1/3. And then component K said that t greater than 1. So the intersection should be which one? So you draw the real number, okay, line number. Negative 1/3 is here. Let's say 1 is here. Okay, component J said that okay, greater and equal. Dark, huh? Okay, component K said t greater than 0, but not included 0. Yes. So the intersection, here, intersection of t greater than equal to negative 1/3. This is t greater than 1. That's why the result, the domain, lastly is only t greater than 1. And t is a member of real number. That's what we call it. To find the domain of vector value function, you have to find domain for each component and then you have to find their intersection. Component J said t greater than equal to negative 1/3 included. That's why it's a dark point. This is a not filled in. You see. So this one means not included 1. T greater than 1. So the intersection will be t greater than 1. So this is a result for the domain. Okay, and then after that, domain found already. Evaluate the limit. Okay, limit. Okay, so for limit, then we'll find, we want the limit for RT at t equal to 1. Limit when t approaches 1. So equal to, find the limit at each component, limit of sin 2t I when t approaches 1 plus limit sub 3t plus 1 component j when t approaches 1 plus limit ln t minus 1 component k when t approaches 1. Okay, and then you find the limit at each component. To find limit, first step is plug in t equal to 1. Sin, when t equal to 1, sin 2. So you have the result, component A, you have sin 2i. Okay, plug in t equal to 1 into the square root function, you have the plus. Okay, t1 3 plus 1 4, square root 4, you have 2j. Okay, component K, when you plug in t equal to 1, 1 minus 1, ln 0. When you plug in t1, 1 minus 1, 0, ln 0 is actually undefined. So component K is undefined. Hence, K, limit RT when t approaches 1 does not exist. Okay, and then similarly, when they ask K, when the limit does not exist, the function K RT is not continuous function. Because limit does not exist, thus RT is not continuous function. So this is question B. As long as limit does not exist, the function RT is not continuous. So this is a question 4B. Okay, question 4C, again, I think is at time t equal to 0, a particle at the origin of an xyz coordinate system has a velocity v naught. So velocity vector, we have I plus 2j minus k. The acceleration function of the particle is at equal to 2t squared I plus j plus cos 2t k. Find the position function of the particle and the speed of the particle at time t equal to 1. Okay, again similar to previous question 4. This one directly gives you acceleration vector. At is 2t squared I plus j plus cos 2t k. So to find the position vector, for that you have to find velocity vector. In given acceleration vector, before you can get position vector, you have to get velocity vector. Okay, Vt is integrate at dt. So we integrate, we have the line in here, 2t squared I plus 1j plus cos 2t k dt. Okay, or you want to write in this form, just bracket dt outside, same thing. So integrations of vector, okay, we still get vector, and the integral constant is a vector 2. So integrate 2t squared, we have 2t cubed divided by 3 at component I. Integrate 1 respect to t, we have t, component k. Integrate cos 2t, you get sin 2t divided by 2. Sin 2t divided by 2, okay, plus your c1. Okay, c1 is a vector. Okay, integrate 2t squared 2t cubed over 3. Integrate 1, get t. Integrate cos 2t sin 2t over 2. This is vector, so this is I plus tj plus sin 2t over 2j plus c1. c1 is a vector. Okay, and they give you, okay, initial vector is I plus 2j minus k when t equal to 0. So that you can use this to find vector c1. Okay, so when t, okay, v0, when t0, plug in 0, component I will be 0, component j is 0, sin 0 is 0. plus C1. Okay, when T0 initial vector even is, initial velocity vector is I plus 2j minus k. So mean 1, 2, negative 1. I plus 2j minus k. Hence, C1, because this is 0. C1 is 1, 2, negative 1. So your Vt here add up with C1. So it will be 2t cubed over 3 plus 1. Component I add up with component I. Component j, t add up with 2. So t plus 2. Component k sin 2t over 2 add up with negative 1. Okay, sin 2t over 2 minus 1. So this is the Vt. Okay, we want to get position vector Rt. So Rt is integrate Vt dt. So we integrate this vector respect to t. Integrate 2t cubed over 3 plus 1. And component I, component j is t plus 2j. Component k is sin 2t over 2 minus 1k. So dt. Integration of vector, you still get vector. The integral constant is a vector. So integrate 2t cubed over 3. You have a 2t power 4. So 3 divided by 4. Integrate 1 is t. Integrate t squared over 2. Integrate 2, 2t. So this component j, component k. Integrate sin is negative cos 2t divided by 2. So initially have 2 here, so total is divided by 4. Integrate negative 1, so negative t. Add up with C2 is a vector. Okay, so you can simplify this one. This is 2 t power 4 over 6 plus t. And then here t squared over 2 plus 2t. Negative cos 2t over 4 minus t plus C2. And then to solve with C2, we need the information when T0. When T0, so plug in T0, component I is 0, component J is 0, cos 0 is 1, so you have negative 1 over 4. This part is 0 plus C2 equal to 1. So look back at the questions. Again, at time t equal to 0, a particle at the origin of an xyz coordinate. So mean when t0, vector rt is 0i, 0j, 0k. Equal to 0i, 0j, 0k. Hence C2 that's 0, 0, 1 over 4. This one bring to right hand side negative. Here is 0, 0. Component I and j is 0. Component k negative 1 over 4 bring to right hand side become positive 1 over 4. It turns RT. Okay. Component I add up with 0. So it's t power 4 over 6 plus t. Component j add up with 0. So it's just t squared over 2 plus 2t. Component k, this one add up with component k from C2. So negative cos 2t over 4 minus t plus 1 over 4. So this is the RT. And the questions 1. Find the position function of the particle and the speed of the particle at time t equal to 1. So, we want to evaluate at t equal to 1. So, we find R1. Plug in t equal to 1. So, you have 1 over 6 plus 1 is 1 over 2 plus 2. Cos 1, so negative cos 2 divided 4 minus 1 plus 1 over 4. Okay, then you can 7 over 6, 2 and a half, so 5 over 2. This is negative cos 2 divided by 4. Okay, so negative 3 over 4. Okay, this is R when t equal to 1. Okay, and then they want to find speed, right? Okay, speed is what? Speed, okay, velocity consists of the magnitude and direction. Speed is actually the magnitude of the velocity. Okay, this is velocity. Speed is actually magnitude of Vt. So means magnitude of a vector. We have a square root, square each component and sum it up. So you will have to square this thing, 2t cubed plus 3 plus 1, square it plus t plus 2, square it plus sin 2t over 2 minus 1, square it. So this is a speed. Else, okay, we find V1. So this is a speed, okay, and then V1, V1 when t equal to 1. When t equal to 1, then the speed when t equal to 1, okay, so plug in t is 1. Okay, t is 1, so it's 2/3 plus 1. So it's 5, okay, 2/3 plus 1, so 5 over 3 squared. So when t is 1, 1 plus 2 is 3, 3 squared is 9. And then t is 1, so you have plus sin 2 over 2 minus 1 squared. So this is 25 over 9 plus 9 plus sin 2 over 2 minus 1 squared. The question 1, position vector in RT at t equal to 1 and also the speed, okay, at time t equal to 1. Speed is the magnitude of RT. Speed without direction. Velocity, we have the magnitude and direction. That's why velocity is a vector. Vector, you have the magnitude and direction. Speed is only magnitude. That's why it's a magnitude of Vt. So to get magnitude of a vector, you have a big square root, and then if you square each component, sum it up. So we just click it here. That's what we want. The question 1 is fit when t equal to 1. So you plug in when t equal to 1. This 2/3 plus 1 squared. Okay. So 2/3 plus 1 is 5/3. Squared is 25/9. T is 1. 1 plus 2 is 3. 3 squared is 9. T is 1. So sin 2/2 minus 1 squared. So it's here, or you can use calculator to evaluate it, get it one floating point number. So we just get manage question 3 and 4. Okay, 3 and 4. Okay, the rest you can try except the curvature and arc length. So behind is actually all speed, velocity, acceleration. Then if you want to practice, unit tangent vector, unit normal vector, you can try question 1, 2, but leave the question curvature arc length after next week. Okay, so do you have any questions?